Hello and welcome to this video on the stack data structure. Now this video is going to be explaining the intuition behind the stack data structure, the way it works, and the functions that we use with the stack data structure. Now as it says, the stack is a data structure, so it stores some kind of data or values or items. So let's just get into it and understand how it works. First off, let's imagine that we have a container and this is going to be our data structure where we store stuff. And to store something in a container, we obviously need objects or items or data. So these four blocks serve as the data that we want to store inside the stack and basically work with. So the first function that the stack data structure utilizes to insert objects inside it or store objects inside it is the push function. Whenever the push function is called, it basically inserts objects in such a fashion, one upon the other, which basically creates a stack, as its name suggests. Now that we've inserted all of these objects, let's understand how to remove objects from a stack. To do that, the stack data structure utilizes the pop function. But the question is, what is the logic behind removing these objects, or what is the sequence in which these objects will be removed? Well, the stack data structure basically follows the last in, first out, or LIFO principle. This basically means that the last element inserted inside the stack is removed first. Now from our example, we know that the last element inserted in our stack was the blue 0. So if we execute the pop function now, it basically removes the element at the top, which is the blue 0. Now the new element on the top of the stack is the green 1. So if we execute the pop function again on the stack, it removes or pops the green 1 from the stack. But how do we know which is the element on the top of the stack? For that, the stack data structure uses this function called the peek function. The peek function basically helps you know which is the item on the top of the stack. In this case, the peek function would return that the value or item on the top of the stack is the pink 2. Awesome. The stack data structure has two more very important functions that it uses. The first one is the isEmpty function. This function basically checks if the stack is empty. Now, if the stack is empty, it returns a true. And if the stack is not empty, which is it has some elements stored in it, it returns false. Another function that a stack has is the isFull function. The isFull function checks if the stack is full, which is you can't add more elements to the stack or it has reached its capacity. If the stack is full, it returns true. If the stack is not full, it returns false. The reason why we have both of these functions is whenever you want to pop an element out of the stack, you always want to check if the stack is empty, because you really can't pop out anything from an empty stack because it does not hold any kind of data or objects or values, right? And the isFull function is always used to check before you push an item or object or value into your stack, because you cannot push anything inside a stack that is already full. Awesome. So let's take a quick recap of what we've learned in this video. First off, a stack follows the last in, first out, or LIFO principle. This means that the last element inserted inside the stack is removed first. Then we have a bunch of functions that our stack data structure works with. The first one is the push function, which helps you add an element at the top of the stack. Next is the pop function, which helps you remove an element from the top of the stack. Next is the peek function, which helps you get the value of the top element in the stack without removing it. Next is the isEmpty function, which helps you check if the stack is empty, and if it is empty, then it basically returns a true or false. It basically tells you whether the stack has any kind of element stored in it or not. And the isFull function helps you check whether the stack is full or has reached its capacity of holding elements. So with this said, Be sure to stay tuned for the next one where we learn how to actually implement the stack data structure using the Python programming language. Until then, have fun and I'll see you in the next one.